Problem number 3. The average family size in the Philippines was reported as 4.25. A random sample of families in a particular state resulted in the following family sizes: 5, 6, 7, 4, 3, 8, 2, and 9. At alpha level equal to 0.10, is the average family size more than the national average? Step 1. We identify the null and alternative hypotheses. If you can recall, the null and alternative hypothesis for this problem is already explained in lesson 7. Pero just recall, the null and alternative hypothesis for this problem is population mean is equal to 4.25 because of the factual statement in the first sentence, and the alternative hypothesis is population mean is greater than 4.25 because of the statement in the question wherein it states that is the average family size more than the national average. Step 2 is identify the level of significance. Identify also if this is under one-tailed or two-tailed test, and get the value for the degrees of freedom. As you can see in the problem, the alpha level is directly stated as 0.10. This is under one-tailed test since in the alternative hypothesis an inequality symbol is used. Next is the degrees of freedom, and the formula is n-1. In this problem, the number of samples is not directly stated, but instead we are just given the raw scores for this given problem. So all you have to do is count those raw scores, and that would be the number of samples. In this problem, we have 8 samples, so substituting we'll have 8 minus 1, and simplifying the degrees of freedom is 7. Step 3 is to identify what statistical test will be used for this given problem. Checking the number of samples in the given problem, we have the number of samples as less than 30. So meaning to say this problem is under one sample t-test. Step 4 is the computation. In the first sentence, the given numerical value is 4.25, and obviously po, that is the population mean because of the phrase average family size in the Philippines. So, parang collectively, the average family size is 4.25 and it represents the population. That's why 4.25 is the population mean. In the second sentence, we have the statement as a random sample of families in a particular state resulted in the following family sizes: 5, 6, 7, 4, 3, 8, 2, and 9. So if you can see, they did not give us the sample mean and sample standard deviation. And what we're given is the raw scores from the sample. So first, we identify how many samples do we have, since that's the first thing that we can come up with is given values, and that is 8 since we have 8 numbers available. And then for the sample mean and the sample standard deviation, we will compute it manually since it is not given directly. Manually computing the sample mean, first we identify our x values. And our x values are 5, 6, 7, 4, 3, 8, 2, and 9. To find the sample mean, we must use the formula summation of x all over n. When we say summation of x, all you have to do is add all the values of x, and then for n naman, all you have to do is count how many x values do we have. Using the x values we have, and substituting the values in our formula, we will have 5 plus 6 plus 7 plus 4 plus 3 plus 8 plus 2 plus 9 all over 8, since we have 8 numbers, or we have 8 x values. Doing this in our calculator, we'll have So the final answer for the sample mean is 5.5. The formula that we're going to use for the sample standard deviation is the square root of the summation of the squared of the quantity of x minus the sample mean all over n minus 1. So the summation of the squared of the difference of x and the sample mean is like parang 1 by 1, you have to get the difference of each x values and subtract it with the sample mean, and then you have to square it. And then you add up everything, then you divide it by n minus 1, and then you get the square root, and that's it. So I will be showing you how are you going to do that for this given x values. Now, we will have for the first x value, which is 5, you have to enclose it in the parentheses and then square it, and then 5 minus the sample mean, which is 5.5, and then squared, plus second value of x, 6 minus yung sample mean natin, which is 5.5, and then square. Tapos plus, the next value for x is 7, then you subtract it by 5.5, then squared, plus the next value of x is 4 minus 5.5 and then square, then plus again 3 minus 5.5 and then square, plus 8 minus 5.5 and then squared, plus 2 minus 5.5 and then squared, plus the last x value is 9 minus 5.5 and then square, all over 8 minus 1. So, parang what we're trying to say is, for each values of x, parang you should subtract it to the sample mean and then you get the square of it. Tapos, i-add natin and then you divide it by x minus 1. N minus 1 rather. And then, you may use your calculator in solving the numerator. We will have 42, and then obviously 8 minus 1 is 7. And then you get the square root of 42 over 7. The answer is 2.45. In the next slide, I will show you how are you going to do that in your calculator. The manual computation is a bit tiring, right? And it's really long. So I'll show you some calculator techniques wherein we will do a short method of solving the sample mean and the sample standard deviation. And all we have to do is press or input the x values in our calculator and press some functions and keys, and we can come up with the sample mean and the standard deviation. First is to press mode, and then you have to press the number equivalent to stat, and then press the number equivalent to 1 minus var, and then this will be the display in your calculator. Next is to input all the x values given in your problem, so by pressing the number itself and then equal sign. So all you have to do is press the number, then equal sign, then proceed with the next number, equal sign, up until you finished all the x values. And then after that, you have to press on. After pressing on, this will be the display, and then you have to look for the function stat in your calculator. Then since it's in the second function, you press shift and then that number. Tapos var, var, and then press yung x bar and then equal sign. Then that would be the sample mean. And then press on again. For the sample standard deviation naman, you press the shift again, then stat, and then var, var, and then sx, or the symbol for sample standard deviation, and that is the sample standard deviation after pressing equal sign. Now that we already have the values for the sample mean and the sample standard deviation, we can now compute for the t computed. And since this problem is under one sample t-test, we have to use the formula for one sample t-test, and that is sample mean minus the population mean all over the sample standard deviation over the square root of n. Substituting the values, we'll have 5.5 minus 4.25 all over 2.45 over the square root of 8. The calculator on the left side shows you how are you going to input the values if your calculator is a 4-liner calculator. And the calculator on the right side shows you how are you going to input the values if your calculator is a 2-liner calculator. Using the calculator, we'll come up with t computed as 1.44. Step 5 is the decision rule. The rule is to reject null hypotheses if the absolute value of t computed is greater than or equal to the absolute value of t tabular. So we have to identify the t tabular first, since we already have the value for the t computed. First, to get the value of t tabular, we have to go back to step 2. Locate your degrees of freedom in the degrees freedom column, and then after finding the numerical value, all you have to do is draw an imaginary horizontal line passing through that degrees of freedom. And since this is under one-tailed test, we have to locate the level of significance into the row adjacent to one-tailed test. Next is the level of significance is equivalent to 0.10. So we have to look for 0.10 into the row adjacent to one-tailed test and draw an imaginary vertical line passing through that 0.10. And the intersection of those two imaginary lines will be our t tabular. That we know the value for our t computed and our t tabular, all we have to do is substitute the given values. Substituting the values for t computed and t tabular, the decision rule will be reject null hypotheses if the absolute value of 1.44 is greater than or equal to the absolute value of 1.415. Step 6, we have to identify if we have to reject the null hypothesis or we failed to reject the null hypothesis. To check whether we reject the null hypothesis or we fail to reject the null hypothesis, we go back to step 5 and check if the given mathematical statement is true or false. We have the absolute value of 1.44 is greater than the absolute value of 1.415. Obviously, this is correct or this is true, so we reject the null hypothesis. Finally, last step, step 7, is we have to draw conclusions based on step 6. Since we reject the null hypothesis, we have to stick to the alternative hypothesis, and that is population mean is greater than 4.25. It only means that the average family size is more than the national average family size.